Okay guys, today I'm going to explain limiting reagent. Limiting reagent. What is limiting reagent? It is the reactant whose given amount is less than the stoichiometric requirement. Whose given amount is less than the stoichiometric requirement. For example, if I write this reaction, hydrogen plus oxygen to form water. Now what is the stoichiometry of this reaction? If this is balanced, then we can write as like this. Sorry, this is 2. Now 2 moles of this number 2, 1, 2. These numbers represent this number, this one and this one. They represent stoichiometric coefficient. Now this stoichiometric coefficient represent number of moles of the reactants and products. This reaction, this stoichiometry represents 2 mole of hydrogen react with 1 mole of oxygen to form 2 mole of water. Now in terms of mass, we can say 2 into 4 gram of hydrogen reacts with 32 gram of oxygen to produce 36 gram of water. So if in the question, if say for example 4 gram of hydrogen is combined with 20 gram of oxygen, for example, then we can decide which of the reactant is the limiting reagent. Now since 4 gram of hydrogen will require 32 gram of oxygen, but here only 20 gram of oxygen is given, so this is the given amount. The stoichiometric requirement is 32 gram. This is 4 gram. Now 4 gram is okay, but 32 gram is required. But this is the stoichiometric requirement to react with 4 gram of hydrogen, but we are given only 20 gram of oxygen. So given amount is less than the stoichiometric requirement. This implies limiting reagent in this particular case is oxygen. Now let us take one more example in the form of question. If this reaction is considered is a balanced chemical reaction, if in this reaction, if 5 mole of hydrogen and 2 mole of nitrogen are reacted, then what will be the mole of ammonia formed? And if ammonia in terms of mole is known, then we can calculate the mass of ammonia produced also, or the mass number of molecules of ammonia produced also. Now let us take in this given condition which reactant is the limiting reagent. Now from this balanced chemical reaction or the stoichiometry of the reaction, 3 mole of hydrogen react with 1 mole of nitrogen to produce 2 mole of ammonia. So with 3 mole of hydrogen, 1 mole of nitrogen will be used. So 3, 1. So what will be the mole of nitrogen required that will react with 5 mole of hydrogen? So that we need to find out here. 3 mole of hydrogen will combine with 1 mole of nitrogen, but we are given 5:2. So for 5 mole of hydrogen will require 5 into 1 divided by 3, that is 5 by 3 is approximately 1.3 to 1.66, something like this. This is the mole of nitrogen required that will react with 5 mole of hydrogen. So required mole is 1, required mole of nitrogen is 1, but we are given more than this 1 mole. So limiting reagent is nitrogen. Let me check again. Stoichiometry requirement is 3:1. For 3 mole, 1 mole is required, and for 5 mole, 5 into 1 divided by 3, that is 1.66 mole of nitrogen is required, but we are given more than this amount. So nitrogen is not the limiting reagent here, hydrogen is the limiting reagent, because our requirement is only 1.66, but we are given more than that. 2 mole of nitrogen is given, so limiting reagent is hydrogen, not nitrogen. So to understand limiting reagent, we need to know the stoichiometry of the reaction. Now let us take one more example. If 50 ml of HCl 0.1 molar and 50 ml of NaOH 0.2 molar are mixed. What is the pH of the mixture formed? Now this question is partly based on limiting reagent and pH. Now what we need to do is HCl plus NaOH. This is acid, this is base. So we need to calculate millimoles here. Millimoles, equal number of millimoles of acid and base will combine to neutralize the reaction. Millimole is nothing but millimole. To calculate millimole, we need to multiply volume of solution in ml by the molarity of the reaction. Now this is 50 into 0.1, that is 5 millimole, and for NaOH the millimole is 5 into 50 into 0.2, that is 10, I think. It's 10. Yes, this is 10. So 5 mole of HCl, 5 millimole of HCl will combine with only 5 millimole of NaOH. So 5 millimole of NaOH will remain. Millimole of NaOH left unreacted, that will be equal to 5 millimole. This implies OH minus ion concentration is 5 into milli means 0.10 to the power minus 3 mole divided by volume of the solution in liter. Volume of the solution will be obtained by adding 50 ml and 50 ml, that is 100, and in liter this will equal to 10 power minus 3. This and this will cancel out, and 5 into 10 power minus 2, that is 5 into 10 to the power minus 2. Now this is the molarity of the hydroxide ion concentration. So therefore we need to calculate H plus ion concentration, so that pH is calculated. pH is H plus is 10 to the power minus 14 divided by 5 into 10 power minus 2, that is 1 by 5 is 0.2 into 10 to the power minus 12, 10 to the minus 12. This is the concentration. This can be written as 2 into 10 power minus 13, 2 into 10 power minus 13. This is 2 into 10 power minus 13. Now from this concentration of H plus ion we need to calculate pH. Therefore pH of the solution will be equal to minus log of H plus ion concentration, which is 13 minus log 2, 13 minus log 2, that is 13 minus log 2 is 0. What is the value of log 2? 0.301 exactly, but I'm writing 0.3 only. This is equal to 12.7. This is the pH of the solution. Now here in this case, the amount of hydrogen required to react with 50 ml of 0.2 molar NaOH is the same amount, that is 50 ml of HCl, 50 ml of HCl, and the molarity has to be 0.2, but only 0.1 is there. So limiting reagent in this case will be HCl, and so the amount of HCl will be finished before the amount of the NaOH. So NaOH will be left, limiting reagent will be HCl, and since NaOH is left, therefore the solution or the mixture will be basic in nature, hence its pH is greater than 7 also. So this is something about stoichiometry, limiting reagent, and pH solution. Thank you guys.